Hi gang, I'm glad you're all here. Thank you for waiting on me to do my report. Yep, Yellowstone is very active today. 109 earthquakes that USGS is reporting that is happening, still ongoing within the last 24 hours. And let's see, the depth, 6.3 miles, 5 miles, 3.6 miles. Look at the depth of these earthquakes. This one here was only 2.2 miles below sea level. All earthquakes are measured from sea level. What looks like is going on is magma is coming into the caldera, pushing up, flowing up to the top of the caldera system. The roof of the caldera is only about 3 miles below sea level. See, this one's shallower, 2.7. So there is cracks forming, dike intrusion, where the magma is coming up. So I thought I would look at the area, the location, where you just don't know. We could possibly have an eruption. Over here is Greeley Lake, Hedgen Lake. This is the location of the 3.1. That was the largest earthquake that was reported by USGS, which was a magnitude 2.6. Here it says was 10.2 kilometers in depth. It was actually 6.3 miles in depth. Yeah, you can see there was a lot of them. Fairly deep, some shallow. There is a lot more than 108 earthquakes. What was going on is drumbeats. And this is very significant drumbeats. This comes from nature.com. It was published May of 2014. Volcanic drumbeat seismicity caused by stick slip motion and magnetic frictional melting. These drumbeats started probably about 7, 8 o'clock last night. During volcanic eruptions, domes of solidifying magma, that's lava when it's still under the ground, it's called magma, can form at the volcano summit. Well, Yellowstone's got 2 summits, got 2 resurgent domes. As magma ascends, goes up, rises up in the ground, it often forms a plug bounded by discrete fault zones, a process accompanied by drumbeat seismicity. The repetitive nature of this seismicity has been attributed to stick-slip motion at fixed loci between the rising plug of magma and the conduit wall. Now that's a good point there, between the conduit wall, the outside edges. Think of water holes where there might be mud or rock stuck in the hose, and as pressure builds, it slowly pushes that rock or mud, the plug, in pulsating measurements until it finally comes free. Here it says, however, the mechanism for such periodic motion remains controversial. What eventually happens with these drum beats is they become so rapid, so fast, so loud that the machines, the seismometers, can't pick them up. That is a term called when the volcano screams, and I've done, maybe about a year ago, I did a report about screaming of Yellowstone. We find that frictional melting is a common consequence of such slip. The melt acts as a viscous brake so that the slip velocity wanes as the melt forms. The melt then solidifies, followed by pressure buildup, which allows fracture and slip to resume. Fracture of the rock, an earthquake. Fractional melt therefore provides a feedback mechanism during the stick-slip process that can accelerate the cycle of such motion. Like I said, this started probably about 7, 8 o'clock last night, Central Daylight Time. The largest movement, let me bring this up, was at Maple Creek. Here we have the borehole. You guys should know that follow me. Probably the new ones don't know. But boreholes are very deep well, bored into the ground about, they probably go down about 600 feet. Here we have an image of the borehole there at Madison River. I'm going to make this larger for you. And we'll come down. The seismometer to measure the earthquakes is 661 feet down. The strain meter is 681 feet down. That is this monitor right here. And let me pull it down and I'll pull it over for you. This is what it was showing when I pulled the files a little while ago. I wanted to do this video earlier, but I was waiting on a delivery. And, yeah, a new stove. My stove went out, so I was waiting on a new oven, and things happened. And when they were supposed to show up, they never showed up. But those of you who have learned to watch Yellowstone knew something major was going on. There is an image they're currently watching Old Faithful go off. Notice how dirty the steam is. That's because of the heated rock that's rising up with the water and the heat. Yeah, I've talked about the melt before and how sometimes these geysers, yeah, they look really dirty sometimes. Geologists know that any volcano in the world can erupt within 10 minutes with no warning at all. The magma coming up from the mantle of the earth can rise up that quick within 10 minutes. No earthquake warnings, nothing. So here's a map showing the location of the current activity. Once again, those that follow me will know when Yellowstone erupted in its last major eruption, it did a counterclockwise unzipping of the caldera. Unzipping means there's small eruptions slowly popping up like a zipper. Small eruptions, boom, 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 boom. Magma, lava coming out of the ground in a counter rotation, going all the way down here to Heart Lake. And when that happened, both resurgent domes, the one there, the Mallard Lake Resurgent Dome at Old Faithful, and the Sour Creek Resurgent Dome, which is kind of like up here in this area above Yellowstone Lake. I'll show you in a minute. Both resurgent domes collapsed at the same time, and then that's when they had their super eruption. The red dotted line is the outside edge of the caldera walls. Notice where we're having the earthquake swarm. Let me zoom in. Can I zoom in? There we go. I'll do that. Let me bring this over. Right close to the caldera wall. And once again, we'll go back to this paper that was published in 2014, the movement between the magma plug and the conduit wall. And here's the 2.6. I'm going to show you. It gets messy. This gets real messy with everything that I got drawn out. Okay, Sour Creek Resurgent Dome up here on the top right. Mallard Lake Resurgent Dome down here. This red line is uplift. And for some reason, this zone of red rises and falls pretty much the same distance for the entire length between the Sour Creek Resurgent Dome and the Mallard Lake Resurgent Dome. When I put the notes on here, it had risen in this location 3 feet and 4 inches. This is what it's currently showing. You can see the very small earthquakes through here, and I'll bring it up to the top. This one here at the bottom is Maple Creek. This one in the middle is Moose Creek. And this is the Madison River borehole. Yeah, it's still picking up. Yeah, we still have magma coming up from the mantle and rising up. Let me show you something. All right, here's the upper magma chamber. There's the Sour Creek Resurgent Dome. I guess I can make it bigger for you. Let me bring it out. Pull this over. This is only about 3 miles under the surface of the earth. There is pockets of melt, which is only about 600 feet from where people are walking. And we got the upper magma chamber, the reserve, And then down farther is where the hot spot, the plume, comes up. So currently what's going on, we got magma coming up through the hot spot, the plume, going up to the magma reserve, and now going into the magma chamber. And I know that because of the depth of the earthquakes. And you notice this area here has rhyolite, which is the most explosive type of magma you can possibly have, full of gases. And then over here is basalt, and that would probably be like the Snake River Plateau. There's actually, now they know, 2 areas where the magma flows into Yellowstone. One through the Snake River Plateau, and the other one actually comes all the way up from the Gulf of Mexico. And then, yeah, we got the hot spot. Yeah. Let me bring this over. And I'm going to show you the depth again of the earthquakes. Yeah, 1.4 miles, 1.5 miles. This is the upper roof of the caldera. You don't want the upper roof to collapse, because when that happens, you'll have a major eruption. Now, this one's deeper, 5.9. That would be below the upper magma chamber. 1.4 mile above. 4.8 miles, 1.3 miles, 2.7, 5.6, 1.6. Let's see what it's showing right now. Okay, so it's settled down at the upper magma chamber, but it's still coming in, yeah, from the plume. That one's shallow, that one's shallow. So it stopped up here. Could just be heating up again for more magma to find a crack, a dike intrusion to come up here. But currently the earthquakes are down in this location, the lower magma chamber, and between the magma reserve or reservoir. These little lines that they got marked out in red, those are supposed to be pockets of melt. But we know there is pockets of melt higher up, like I said, 600 feet under where people are walking. But these are known pockets of melt. This earthquake right here is a magnitude 2.36. Yeah, and where's the one? Let's find the other one. This is that 2.6, but I got a 2.89 on it. And let's pull it over a little bit so we can see. And I want to see what it's doing when I pulled the files. It doesn't look too bad. We're still having the earthquakes. Moose Creek, Idaho looks more significant. Yeah, you can see the lines of melt here. Yeah, that's more significant. Let me bring it up and find the other earthquakes. Okay, this is the one that was supposed to be the 2.6. And we got that one. We'll look at the signature. That one there. Let's see. We got another large one over here. Yeah, they're actually much larger than what they're reporting. Let's take a look at the spectrogram. Yeah, 2 earthquakes there. And then the reason I came over here, because this one was showing blobs of melt. Let's look at the signature. This is tectonic earthquakes causing this motion, and just like the Ring of Fire, where you got areas that the continents collide. Yeah, and you're going to have plate movement. This is definitely plate movement here that's causing all this. Let's make this bigger. Now this is volcanic earthquakes taken from what I just pulled a little while ago. There's the very end of what I pulled. Yeah, these are volcanic earthquakes. They were just moving the camera a little bit. It is breezy there. You can see once in a while the trees shaking. It's supposed to be winds about 10 miles an hour. So you can't really go by the camera shaking, but we can go by the monitor, what it's showing. And look at the dead trees now. That has definitely increased. The trees that died grew up what's called the quiet period before the gases of the recharging of Yellowstone's volcano. And as the gases come up, they kill the trees from the root up. And then I noticed if they come over a little bit farther, up here at the top, this area of dead trees is actually getting wider. This here is the Firehole River. So they're taking a scan, looking back and forth right now. Looks like we got some buffalo over there. Right there. They have this on top of the hotel. The camera is on top of the hotel. We'll just watch and see which direction they move it. Down over here is another hot spot where heated water comes up right there. And about 2 years ago they put cones around that to keep people out of the area. Yeah, they're giving us a good view of what's going on right now. Yeah, this is the line of trees that comes up from one of the springs. Is getting wider. But anyways, if you think that they're going to tell you that they think Yellowstone's going to erupt, they won't. They will not give you any warning whatsoever. And there's not much you can do. Everything within 500 miles, would be pretty well destroyed. Closer would be vaporized if it's a large eruption. You could have a small eruption. There's been over 40 smaller eruptions since its last major eruption, which was 635,000 years ago. The most recent eruption was along the Snake River Plateau. There was one there about 10,000 years ago, and another one not quite as far back. I used to like it when they had these large earthquakes and they would look at the cliffs up over here and you could see the rock slides that were going on. And what it's showing, these are blobs of magma. So blobs of magma at Maple Creek and Moose Creek. All right, here's the monitor, the borehole for Madison River, right there. This one right here is Maple Creek. And then down over here, see if I can find it again. All right, I think that's it. Moose Creek, Idaho. So this monitor here and this one right here, the borehole, is showing the most intrusion of the magma. I moved it around, these two around, so I have them next to each other. Borehole 207, Moose Creek, Idaho, right there. You see the drum beats here. You can see the thickening of the lines. But then we got Maple Creek showing the smaller earthquakes. A lot more of smaller earthquakes. Alright, so what I did here was draw out in yellow from Moose Creek, Idaho's monitor to the borehole there at Madison River, all the way down to the monitor at Moose Creek, Idaho. I thought that would make it easier. Over here is Heart Lake. It would be right there. And like I said before, when it did its unzipping, it did a counterclockwise unzipping. Yeah. I hope you can see all that. So you guys are just going to have to keep an eye on it. They're not going to report all the earthquakes. You know that. Be aware of what your animals are doing. What can I say? Please stay safe. Always be prepared. Not much you can do if it decides to erupt. And any volcano can erupt within 10 minutes with no warning at all. Thank you for watching. Thank you very much for your support. Thank you for subscribing. Please stay safe, and I'll talk to you later. God bless you. Bye.